Hello, and welcome to Connection of the Month, the series where we take you inside the HSS Connections Hub. I'm Ted Goldstein, structural engineer with Atlas 2, and this month we're going to be looking at the wide flange beam to HSS column wraparound moment connection. This is a great connection if you've got a high level of force and you don't want to have to cut the column to insert a diaphragm plate. We're also going to look at a new feature inside the HSS Connections Hub. So with that, let's jump right in. All right, so here I've gone ahead and put together a wraparound moment connection. And before we jump into the numbers, a few things to mention. First of all, we've got some pretty sizable beams and forces here. We have W27 beam, 14-inch square by 3/4-inch thick column. And we've gone ahead and put quite a bit of moment on it. So if we look at the loads, on each side of the connection, we have 50 kips of axial load from the seismic case, quite a bit of shear, and 400 kip feet of moment. So these are quite significant loads. And indeed, if we look up at the load combination, we're at 448 kip feet of factored moment in the connection. Now, this may well be a little more than this particular type of this size column can handle, but of course, the member level analysis is going to happen in your modeling software. We're really just looking at the connection here. Another thing to point out is that, when you have one of these more complex connections that have a lot of different elements to it, sometimes the 2D diagrams can get a little difficult to follow. So to address that, we've actually gone ahead and now implemented some 3D diagrams. So this is currently available just for the wide flange beam to HSS column moment connections, but we do plan to roll this out for all connections in the near future. And in addition to just giving you a visual sense of what the connection looks like and allowing you to pan and rotate, we actually also let you go ahead and select the various elements and get information. So if we click on the column, we get the column size, including its design wall thickness. We can click on the bolts to get their size, or we can even go so far as to zoom in and click on the weld, and it'll give us both the length and the leg length of that weld. So it makes it much more intuitive to understand, how the various parameters we're entering on the left side here to define the connection, what those correspond to in the actual physical connection. So with that in mind, let's jump into the math a little bit here. As I say, I've put a lot of load on this connection, and in terms of the shear, we're doing okay. Maximum shear limit state is at 73%. Could potentially remove a bolt from the web, but we'll leave that for now. But we do have a limit state that is at 125%, and that right now is the slip resistance of the bolts. And indeed, if we come down here on the left side and we scroll all the way down, we can look at those bolt capacities in more detail. So we're governed, not surprisingly, by slip resistance. Anytime you have a slip critical connection, there's a good chance that slip is going to govern. So let's see if we can get that down. It's pretty straightforward to do, of course. Right now we're using 7/8 inch diameter A325s. If we simply go up to 1 inch A490s, honestly, one of those changes might have been enough. You can see now the bolt limit state is down at about 75%. So no problem there. That's straightforward enough. We do still have a limit state up here at 109%, and it says the required axial force is greater than the compressive strength of the cutout plate. So the cutout plate is what I've also been calling the wraparound plate. Really here it's shown as one continuous plate, but of course in practice you would have two C shapes, which you're going to cut and then slide around the column and weld back together. And these plates are what transmit the force from the flange of the beam. It goes through the bolts into these plates, and then it has to get out to the side walls of the column. Just in the same way if you were doing a moment connection to the strong axis of a wide flange column, we would have to get that load from the flange of the beam into the web. Here we're going into the sidewalls. And actually one nice thing about HSS columns is you've got a lot more material in the sidewalls than you would normally have in the web of a wide flange column. So having to do panel zone reinforcing or anything like that is extremely rare with an HSS. But again, we're a little bit over, so that's also quite straightforward to deal with. Here we have the plate inputs. So we have our cutout plate thickness and the width. And really we can, choose either one that we want to adjust to get this down to have the connection work. So obviously if we make the plate a little thicker, that gives us more meat and we're down to 84. Similarly, we could make the same get the same result by changing the width instead of the thickness, and that will also get us down. And you can see here, now that we've made that change, we have a little more width adjacent to the side wall of the column, and that's enough material to get the load into the column. Now, we wouldn't want to go too wide here, both for practical reasons. If you were on, for example, the perimeter of your building, you wouldn't want a plate sticking out way past the column, but also because if this plate starts to get too wide, there's a potential for buckling. So we want it to be relatively compact to avoid that. So as you can see, pretty straightforward to get this connection to work, even despite the fact that it's a large amount of force. And that is what the wraparound connection is most useful for. So really appreciate you joining us this month on the connection of the month, and certainly hope to see you next month.